Alright, another proof. Prove the alternate interior angles converse theorem. That's all they say. They don't give me any more. So if I'm trying to prove the alternate interior angles converse theorem, they basically give me the setup in the phrasing of the problem. Go ahead, take a quick look at the problem or the theorem again. If you saw this and you saw that alternate interior angles converse theorem started with if two lines are intersected by a transversal. So I'm going to draw two lines intersected by a transversal. Line M and N are intersected by a transversal. The next thing it says, and the alternate interior angles are congruent. So the next thing I'm going to do is I'm going to choose two alternate interior angles, and I chose angle 3, that's extra, but I'm going to be able to say angle 1 and angle 2 are congruent. Alternate interior angles are congruent. And what I'm trying to prove, the then part of the alternate interior angles converse theorem is then the lines are parallel. So in this case, line M is parallel to line N. If I get that, that's what I'm going for. At this point, it's time to do my proof. So, statements, reasons, always copy down the given first. That's the nice one. Angle 1 is congruent to angle 2, given. Great. The next thing I do, I don't know where to go from there. I could say measure of angle 1 equals measure of angle 2. However, if I'm trying to show lines are parallel, I need the angles being congruent, not measures being equal. So I'm looking, well, I can't say angle 1 and angle 3 are congruent because I don't know if the lines are parallel yet. I'm trying to prove they're parallel, so, well, what about 2 and 3? Oh, perfect. Angle 2 and angle 3 are vertical angles. And vertical angles have to be congruent because vertical angle congruence theorem, or all vertical angles are congruent. So angle 3 is congruent to angle 2, vertical angle congruence theorem. The next thing, well, I have angle 1 and angle 3 both being congruent to angle 2. Well, if they're both congruent to angle 2, they have to be congruent to each other. Angle 1 is congruent to angle 3, and the reason I know this is because they're both congruent to angle 2. But the official reason I state is the transitive property. And last but not least, if I have angle 1 and angle 3 being congruent, those are corresponding angles, they're congruent, and I know that if corresponding angles are congruent, then the lines have to be parallel, and the beautiful thing about that is the corresponding angles converse is a postulate. I never have to worry about proving that one. I can always use postulates in a proof. So if I pull up the corresponding angles converse postulate here, my proof is done. I have just shown you that the alternate interior angles converse theorem has to be true if we accept the corresponding angles converse postulate. That's where all of these other three are built off of. If we don't accept that postulate, this fails. There is one additional part of this that I do need to talk about. In this section, they added a paragraph proof, which instead of putting it into two column like this, what they sort of do is they take what I have here and then they put it into paragraph proof form. To help us out a little bit, I'm going to recopy the chart here so we have something to look at. Now, if I was going to put this into words, I would say something like, it is given that angle 1 is congruent to angle 2. Angle 2 and angle 3 are vertical angles, and they are congruent to each other because of the vertical angle congruence theorem. I have angle 2 being congruent to both angle 3 and angle 1. And that means angle 1 is congruent to angle 3 by the transitive property. And now that I'm reaching my conclusion, I would bring out the thus. I really like thus. It makes me sound smart or scientific. Or therefore. Therefore just makes you sound smart instead of saying finally. That makes it sound like you're just trying to get it over with. We want to sound smart. So thus or therefore. Line M and line N have to be parallel by the corresponding angles converse postulate. This is what I ended up writing for you to actually physically see. But if you want to use the words that I just did, that's fine. Again, you still have statements, you still have reasons, and you're giving them as you go along. But now we're putting them in sentence form. When you get to college and you're taking a junior level math course, if you are doing this, if you're doing a proof, you're doing it this way in a paragraph form. You're going to be doing it a little bit better than what I did there, but you will be doing it that way. Well, it's your choice at this point, unless specifically stated in a problem, whether to use a paragraph proof or a 2-column. Personally, I like 2-column for geometry. I think it's a pretty nice format. However, paragraph proofs will prepare you better for something in college. Well, that's it for today. Have a good rest of your day.